Determine when a particle is moving left or right. So in this video, we're going to briefly discuss rectilinear motion. Now, what is rectilinear motion, you might ask? Well, rectilinear motion, sometimes referred to as linear motion, is motion that happens in one dimension. So that means it's either going to go left to right or up and down. And that's what a lot of the motion is that we're going to be going over in this particular calculus course. All right, so in order to talk about linear motion, we need to talk about velocity versus speed. So speed represents the change in distance, i.e., how fast an object is moving. Velocity, on the other hand, represents the speed and the direction of an object. So the velocity is more than just speed. Velocity is speed and direction of an object. So, how do we figure out the difference between speed and velocity? Well, in order to find speed, we just take the absolute value of the velocity, because speed is always positive. We as human beings haven't figured out how to go negative 55 miles an hour on the highway yet. That would, of course, cause lots of accidents, so let's hope that we never do. But speed is always positive. Velocity, however, since it represents the direction of the object, can be either positive or negative. So let's talk about that. What happens when the velocity is positive or negative? Well, depending on whether the velocity is positive or negative, that determines which direction our object is moving. So, if our velocity function is greater than 0, aka our velocity is positive, we know that the object is going to be moving forwards. Now, depending on how the object moves, forward might mean up, or it might mean to the right, depending on what the question tells us. If the velocity is less than 0, or if the velocity is negative, our object is moving backwards. And again, backwards, depending on how we're moving, might be down, or might be left. All right, so great. We know that when velocity is positive, it's moving forwards. When the velocity is negative, it's moving backwards. That covers all of our bases. Almost. Because there's one number in math that is neither negative or positive. So what happens when our velocity is 0? Well, if the velocity is neither negative or positive, meaning it must be 0, that means our object is not moving. And there are two situations when our object is not moving. It is either at rest for good, and it's too tired, it hasn't started yet, it needs a nap, or our velocity is changing directions. Because in linear motion, you can't make a U-turn. So in order to change directions, in linear motion, you can be going in one direction, and then all of a sudden you have to stop in order to start going in the opposite direction. There are no U-turns in linear motion. So that's how we know if the velocity is 0, it's either not moving or it is changing directions. All right, great. So that's velocity. But how do we... Great. So now we know the direction that the All right, great. So now we know the direction an object moves. All right, great. So now we know what direction an object moves based on the velocity, but that's only half of what the velocity tells us. The velocity also tells us the speed. So how do we figure out if an object is increasing or decreasing in speed? Well, if the velocity and the acceleration have the same sides, that means the object is speeding up. So same sides mean speeding up. So if the velocity is positive and the acceleration is positive, we're speeding up. Great, that makes sense. But if the velocity is negative and the acceleration is negative, we are also speeding up. And that kind of gives students a pause, like, wait a second. If they're negative, how are we speeding up? Well, I like to think about it as if they have the same signs. That means the velocity and acceleration are working together. Teamwork makes the dream work. So if they're working together, they're being very efficient, and they're being very fast. They're speeding up their work. So if the velocity and acceleration work together, have the same sign, that means they are speeding up. However, if the velocity and the acceleration have different signs, meaning one's positive and one's negative, or one's negative and one's positive, that means the object is slowing down. And I like to think about it that in a way that means the velocity and acceleration are working against each other. They are butting heads, they're arguing, they're not getting the job done, so therefore they are slowing down. So again, same signs, speeding up, different signs, slowing down. All right, so let's take a look at our first example. In our first example, a particle moves along a coordinate axis. Its position at time t is given by s of t equals negative 3/2 t squared plus 4t plus 10. And we're being asked, when is the particle moving to the left, when is it moving to the right, and when is it stationary? All right, so let's dive in. So we know that when an object is moving left, the velocity, v of t, is going to be negative. We know that when our object is moving right, the velocity, or v of t, is going to be positive. And then when our object is stationary, we know that our velocity function is going to be 0. Well, notice how all these things deal with the velocity function. So we should probably start out by finding the velocity function. So v of t, remember we said, is the derivative of s of t. And we can find the derivative of s of t, no problem. So we're going to use the power rule here. We're going to take the 2 times the 3/2, 2 times the negative 3/2, and that's going to give us negative 3t. Then we're going to subtract 1 from the exponent, and that'll just give us negative 3t to the first, or negative 3t. Then we'll take the derivative of 4t, which will be plus 4, and the derivative of 10 is 0. So there we have it. We have our velocity function. Now we just need to figure out when it's positive, when it's negative, and when it's 0. Well, let's talk about when it's equal to 0 first, because that's the easiest thing to do. We can just set our velocity function equal to 0, and then we can solve for t. So to solve for t, I'm going to add 3t to both sides, and that's going to give us 3t is equal to 4. And then we can come in and we can divide both sides by 3. So therefore, t is going to be 4/3. So t equals 4/3 is when the object is stationary. Now, how do we figure out when the velocity is positive or when the velocity is negative? Well, to do that, we're going to use a sign chart. So we know that we are going to have a number line, and our number line is going to go from negative infinity to positive infinity, because our velocity function is a polynomial, and that means the domain of a polynomial is all real numbers. Now, on our sign chart, or on our number line, we're going to plot when the velocity is 0, and that is at 4/3. So to figure out when the velocity is positive or negative, we need to pick a number in each of the intervals that we just made. Because by plotting 4/3, we created the interval negative infinity to 4/3, and then the interval from 4/3 to infinity. So we're going to pick a t value in this interval. So in my first interval, I'm going to choose t equals 0. And in my second interval, I'm going to choose t equals 2. Now, I'm going to plug these t values in to the velocity function. And when I plug in 0, so v of 0, that's going to give us a value of 4. And we can see that 4 is greater than 0. So that means over the interval from negative infinity to 4/3, we are going to be moving to the right. Then for the next interval, we're going to do v of 2, meaning we're plugging t equals 2 into our velocity function. So that's going to be negative 3 times 2 plus 4. And that's going to give us a value of negative 2. And negative 2 is less than 0, which means over this interval, we're going to be moving to the left. All right, so now let's just quickly summarize what we got. So let's see. The particle is moving right over negative infinity to 4/3. Our particle is moving left over the interval 4/3 to infinity. And then finally, our particle is stationary at 4/3. And there we have it. We have now figured out when the particle is moving left, when it's moving right, and when it is stationary. All right, in this example, we're told a particle moves along a coordinate axis. Its position at time t is given by p of t equals negative 4t cubed plus 7t squared minus 3t plus 8. And we're being asked, is the particle moving to the left or to the right at t equals 2? Well, we know that if a particle is moving to the left, that means that our velocity function is going to be less than 0. If it's moving to the right, that means our velocity function will be greater than 0. So, first thing we need to do, find our velocity function. And we know that our velocity function is the derivative of our position function. And that's pretty easy to find with this given position function. So we're going to take the derivative of negative 4t cubed, which will be negative 12t squared, plus the derivative of 7t squared, which is 14t, minus the derivative of 3t, which is 3, and the derivative of 8 is 0. So now we have our velocity function. And we need to find the velocity when t equals 0. So we'll substitute that in. So v of 2 is going to be negative 12 times 2 squared plus 14 times 2 minus 3. Which, let's see, that's going to be negative 12 times 4 plus 14 times 2 is 28 minus 3. So this is going to be negative 48 plus 28 minus 3, which will give us a value of negative 23. Well, if we look here, we can see that negative 23 is less than 0, which means that our particle is moving left at t equals 2. So the particle is moving left at t equals 2. And there we go. Answered. All right, so our next example, we're given a particle moves along a coordinate axis. Its position at time t is given by the function p of t is equal to t cubed minus 3t plus 5. And this question is asking whether or not the particle is moving to the left or to the right at t equals negative 1. So this is a little bit different of a question. It's not asking us to describe the motion over the entire interval. It's asking us to find the motion at one particular point. So we know that in order to determine whether a particle is moving left or right, we need to look at our velocity function. And we know that the velocity function is equal to the derivative of the position function. And we can easily take the derivative of the position function. That's going to be 3t squared minus 3. Now, we want to find the velocity at t equals negative 1. So we'll substitute negative 1 in for t, giving us 3 times negative 1 squared minus 3. And then we can continue calculating this. Let's see, negative 1 squared is 1. 1 times 3 is 3. 3 minus 3 is 0. So therefore, we know that v of negative 1 is going to be 0, which means it's neither moving left nor right, which is fine. That can happen. And since it's moving neither left or right, we know that it's at rest. So therefore, at t equals -1, the particle is at rest, which means it could not be moving or that it's changing directions. All right, in our final example, a particle moves along a coordinate axis. Its position at time t is given by p of t equals -3/2 t squared plus t minus 5. Same as always. Now, what time does the particle switch directions? Well, this is key here, because we know the particle switches directions when our velocity function equals 0. So, in order to find the time, we need to find the velocity function, set it equal to 0, and solve for t. So, we know the velocity function is equal to the derivative of the position function. So v of t is going to be, let's see, we will use the power rule, and we're going to end up with -3t plus 1. And we say we need to set the velocity equal to 0, so -3t plus 1. Then we want to get the t by itself, so I'm going to add 3t to both sides. That's going to give me 3t is equal to 1. Then we can divide both sides by 3 to find out that our particle is switching directions at t equals 1/3. All right, folks, that is it. That is determining when a particle is moving left or right.